using the Fourier transform. In previous lectures, I discussed about the properties and the basics of Fourier transform, how we can transform the Fourier transform any signal into Fourier transform. So in this lecture, I actually trying to discuss about the Fourier transform using Fourier transform properties, as I discussed in previous videos. So firstly, if we want to transform these e to the power at ut, so this xt, we first attempt would be what properties or what basic transformation, Fourier transformation we already have seen or we know, and we should think about the known Fourier transform that we have discussed in earlier. So in the right side, actually I incorporated those properties or those laws, if I say in this way. So we already know that if you have the Fourier transform of xt is x omega, then if we need to transform the x of minus t, then just replace the x omega by x minus omega. So in this case, we need to determine the Fourier transform of e to the power minus at ut, but we already know the Fourier transform of e to the power at u minus t is 1 divided by a minus j omega t. And we also know that if we have the Fourier transform of xt is given by x omega, we just need to replace x omega by x of minus omega. So in this case, just different is that u of minus t, here u of t, and e to the power minus at and e to the power t. So if we compare these two signals, two functions, basically the difference is that t is replaced by the minus t. So here t is replaced by the minus t and t is replaced by the minus t. So from the properties of Fourier transform, if we have the Fourier again I am saying that if we have the Fourier transform of xt like x of omega, then if we have to determine the x of minus t, just replace x omega by x of minus omega. So in this similar fashion, as we have the Fourier transform of e to the power at u minus t is given by 1 divided by a minus j omega, as I have discussed in previous videos. So just we need to replace x of omega. This is in this case this is x of omega, so we need to replace this omega by minus omega. So here the Fourier transform we need to transform, just we need to replace omega by omega minus omega. So this will be the final Fourier transformation. So basically the Fourier transform, in Fourier transform we basically perform the integration, but in many cases where we actually have the in some known Fourier transformation or basic laws or properties, then we can transform or we can short our calculation, as in this video I am discussing. So another function, if we want to transform like xt, here xt is given by t e to the power minus 2t ut. So as I have said, first of all we need to think what the properties or what the transformation we already know or we already have seen. So we already have seen that if we have the Fourier transform of xt is given by x omega, then when we want to determine the txt, then just x omega would be multiplied by j a divided by d omega. So not multiplication, it would be the differentiation in terms of omega. So this like that, and another thing that e to the power minus at, like e to the power minus at into ut. So if we think that this is a function or signal that we need to transform, so this part, the Fourier transform of this part is already known to us. That means in this fashion, that means if we want to transform like this fashion, we just need to place 1 divided by a plus j omega. Here a is here, in this case a is given by 2. So the Fourier transform of that part and if we think that this is the x1t, so the Fourier transform of that would be 1 divided by 2 plus j omega actually. And the another property of Fourier transform suggests that if we have the Fourier transform of xt is given by x omega, just we need to differentiate it with in terms of omega for having the t multiplied by xt. So here t is multiplied with that term, and we know the Fourier transform of that term is what is that. So the Fourier we in this case we basically need to differentiate the Fourier transform of that part. So basically I have tried several times to after by what should I say, by saying over and over again. Just you need to think and pause this video after seeing these two properties, and if you compare these functions. So basically we as I have said, we know the Fourier transform of that part is 1 divided by 2 plus j omega, and we as we know that if we have any known Fourier transformation like xt is given by s omega, and if you need to transform t xt, that means multiplied xt is multiplied by t. Here this part is multiplied with t. So basically we need to differentiate 1 divided by 2 plus j omega, and this would be the final result. And for this transformation or this property suggested that the after differentiating you need to multiply with the term j. So this is the final answer of final Fourier transform of that function. So basically after in this lecture, in these videos, actually I am trying to discuss and I am trying to help you how to transform the transform actually any signal in the Fourier transform actually by the Fourier transform, how you convert from time domain to significant domain by using the properties of Fourier transform. So if we consider another function or signal like e to the power j omega j2, if xt is given by like that. So in similar way as we have discussed in earlier, that e to the power j omega t ut, this is not the similar in case of that, because here no imaginary part was presented, and here there is a imaginary part. So how could we solve this? Actually we have the properties. If you want to transform any signal to Fourier in terms of Fourier transform, and if you have the Fourier transform of xt is x omega, and if you need to transform like this fashion, here if we compare with that, this is the xt and this is the e to the power j omega t. Here omega naught is 2. So how could we transform that? As we know that the Fourier transformation of xt, so we need to have the Fourier transform of xt is given by x omega. Here xt is u of t, so we need to think, or we need to find the Fourier transform of ut. So we know the Fourier transform of ut is pi del omega plus 1 divided by j omega, as I have discussed in previous videos, or back in 2 or 3 videos, or here you can see. So as we know the Fourier transform of ut, so basically in this case we need to replace this part with omega minus omega naught. Here we will replace the omega by omega minus omega naught. Here is the case. So here in this case omega naught is 2, so omega would be replaced by the omega minus 2. It is the final answer. So without performing the integration, as I have discussed in several 2 or 3 slides starting this lecture playlist, we don't need to perform the integration as in conventional. When you are being asked or you will be asked by to determine the Fourier transform using Fourier transform properties, you need to just practice the basic transformation laws or rules or properties, or some rules actually. Then implementing those, you can simply be able to transform from any functional signal to in the way of Fourier transform. So if you are asked to transform the Fourier transform this function xt, then what would be the scenario? So actually here if you think that here 1 is hidden in compared to that, here e to the power j omega naught t, so e to the power j omega naught t. If we think that 1 is multiplied with that, and that one would be the xt, and we already know the Fourier transform of 1 is twice pi del omega, so our goal would be solved. So if you compare these, the xt would be 1, so you need to determine the Fourier transform of 1, and Fourier transform of 1 is twice pi del omega, so you need to replace the twice pi del omega by omega minus omega naught. So what would be the value of omega naught? Omega naught would be the here just omega naught is omega naught, so not in this case omega naught was the 2, omega naught was 2, but in this case omega naught is omega naught, so omega would be replaced by the omega minus omega naught. I think I hope you understood all the things I am presenting here. The final one in this presentation is xt e to the power minus t minus 2 t, and already we know the Fourier transform of e to the power minus a mode of t, as I have discussed in previous video, that the Fourier transform of that function is twice a square plus omega a square, but the difference is that t is replaced by t minus 2. So here in comparison with that, we can understand that we should use the properties of time shifting. This is the property I already discussed in previous videos, that if you have to determine the x of t minus t naught, the Fourier transform would be just e to the power minus j omega naught would be multiplied with the x omega, here x omega is given by the Fourier transform of x of t. So in this case we need to have the Fourier transform of e to the power minus a t, because we need to transform e to the power minus t a t minus 2 with the help of these properties. So we know the Fourier transform of that, but as here the problem is given by the time shifting, so t is in this case t is replaced by t minus 2, so our destination would be x omega, or this term would be multiplied by e to the power minus j omega t naught. So that is the final answer, and basically in this fashion we simply can short our calculation, and we basically try in this video, actually I am trying to present how we can use the properties of Fourier transform for determining the Fourier transform of any signal. So thanks for watching. In coming videos I will discuss another functional signal step by step.